So hi, and let's see some gate questions now. So we have done lattice and some properties of that. So let's continue with questions. Okay, so it will give you your preparation a better edge. So before moving on to question, one thing I need to tell you that see, I just a week back or few days back, I got a message on LinkedIn that someone asking me that what he should do, that because his syllabus is not finished. I am in my previous video and once I have said, once or before, a lot of times I have said that practice test series, topic test. Okay, so if you go back and watch, I have uploaded the videos. I've started uploading from March. Okay, February, March, April. So in those times I have told you to focusing on tests and 30 years of PYQs. So I'll tell you, if you don't have time, don't stress about this. Okay, so you have to do this much of questions, gate questions, topic test. So you just focus on one thing, one subject, and very important that revise. Okay, so I have already told you I did blunder by not revising the first time, so don't do that. So because you're if you do not revise the subjects you have prepared, this will just make your case worse, because you are already putting so much of effort in doing subjects. But if you cannot see, you don't have to remember anything. See, we are computer science engineers, we don't have to remember anything, but we have to practice so that we can answer the questions in our actual tests. So just even if you don't get time of doing so much of gate questions and all, you can watch my videos. If you are following my videos, the questions I am doing, you can follow that, do that by your own. Just pause the video, do the question. If you cannot do, you can just pause, unpause it, and you can watch it. Another thing is that topic test, if you get time, do one or two obviously, but revision is must. Okay, so you just don't finish one subject and go by one subjects, but please revise. Okay, give some time, like in a week, on weekends you can give some time, or any day when you are not preparing full day, so you can just give some time on revision, or before sleeping you can just revise your copy, just skim through your pages. Okay, so you can do that. So this is very important, I wanted to tell you this. And now let's see questions. Okay, so now Hussey diagram, this is a question on Hussey diagram. So Hussey diagram we have done. So let's see the question. See, this was asked in 1996, 1 mark question. This is easy question. Okay, so if I find more complex questions in upcoming years, I will obviously do that. Okay, so this is a easy question. I have taken the easy one first. So here x is, let x is 2, 3, 6, 12, 24. This is our set, and this is be a partial ordered defined by x is less than equals to y. So this is less than equals to sign if x divides y. So now they are asking the number of edges in the Hussey diagram. So basically they are asking the number of edges in this Hussey diagram. So you can see 2, 3, 6, 2, 3, 6, 12, 24. These are all the numbers. So 1 is not present. So we have to see if 1 is present. 1 is divisor of every number. So 2 and 3 both not related to each other. So we have to put 2 and 3 like this. Now next 6. 6 is there. So 6 can be placed here. 2 and 3 can divide, both can divide 6. Okay. So next is 12. So 6 can divide 12. Okay, so next is, this is 24. Why I am writing like this? Now next is 24. 12 can be divisor of 24 and all this. Okay, so now let's see. So this is our Hussey diagram. So now let's focus on what is our this number of edges. They are asking number of edges in this graph. Number of edges. So 1, 2, 3 and 4. So the answer is B. Number of edges is 4 here. Okay. So this is actually easy question. Let's see some more questions. So now let's see this question. This was asked in 2004, 2 marks question. Okay. So now here, so the inclusion of which of the following sets into this is already a set given. So you have to include one more set is necessary and sufficient to make this S a complete lattice under the partial order defined by set containment. Okay, so these are the some options given. So you have to find out, we have to include any one or more than one sufficient to make S a complete. So you have to add set. Okay, so that it becomes a complete lattice. So now first is 1, 2. So let's see, put 1, 2 here, 1 and 2. then we have 1 2 3. So let me put here. Okay, so let's first take 1 and 2. So 1 and 2, let's put it here. Now next is 1 2 3. So 1 2 and 3, let's put it somewhere here. Then 1 3 5. Okay, so this is not common, so somewhere let's put here 1 3 5. 2 is not common, so it is not possible to put a edge here, put an edge here. So 1 2 4, it is common. So let's take 1 2 and 4. So it's not hanging. Okay, so we are not done with this diagram. So now let's see, the final is containing all. So this is containing like this, containing 1 2 3 4 and 5. Okay. So now we have to see, we have to make adjustment and add set so that it becomes a complete lattice. So you can just see, if we just put this take a set which is containing only 1, it becomes a complete lattice. Okay, like this. So we don't have to add all this. Okay, so this is just the necessary and sufficient case. So if we take any two groups, the LUB and GLB exist for all, so we can just add this one and this becomes a complete lattice. So now the option is option A here. So we can just add one, so we need not add all this. Okay, so this is one question. Let's see another question. Now let's see this question. This was asked in GATE 2005 1 mark question. Okay, so now let's see, the following Hussey diagram of poset ABCDE and the relation is less than equals to is given. Okay, so now this is our, and the graph is also given, the Hussey diagram is also given. So they are asking some questions. The poset is a lattice, not a lattice, lattice but not distributive. So I have already told you in the previous video before this that try to remember the L1 star and L2 star. So this is basically L1 star. Okay, so this is just L1 star. So what we have seen, the L1 star and L2 star are both lattices, but they are not distributive lattice. So you can just directly say this is a lattice, but it is not a distributive lattice. So not a distributive lattice. Okay, so if you try to find out from this, you can obviously find it out, but it will take some time. But if you have a practice and good grip on this, so you can just by checking the options, you can find not even by checking, you just have to check the option and take the correct one. Okay, so we know this is not a distributive lattice. Okay, so the answer is B, a lattice but not a distributive lattice. So not a lattice, it's false, it is actually a lattice. A distributive lattice, so this is false. So it cannot be a Boolean algebra because it is not distributive lattice. So Boolean, obviously it can be complemented lattice, but since one option is failing, so Boolean algebra will not be possible. Okay, so we have seen I think 3 questions, we will see more. So keep watching. Okay, so keep practicing and keep watching. After that we will do group theory. Okay, so that is very very important. So actually just have to practice. So set theory in algebra is totally easy and you can score marks here. Okay, so let's continue with this. Okay, so we have seen few questions, we will see some more now. So now let's see this question. This was asked in GATE 2008 2 marks question, and it was asked in IT paper. Okay, so consider the following Hussey diagram. So 4 diagrams are given, so you have to find out which one of the following represent a lattice. Okay, so first is this one, first one. You can see this is very easy, a basic one. Okay, so here LUV and GLB are unique for every pair. So this is our lattice. Okay, so now let's see here next one. So here A, B, C, D, E. So let's say I have given the names. Okay, no, names are not given. Actually I have made the video and the video got stopped actually, so that's why the names are given, but names are this are variables are not given in the question. So this the diagrams are given. So here if you take B, D and B, so these are not unique. Okay, LUB and GLB needs to be unique for any pair. Okay, so but here BD, it can be C and E also. Okay, so this is not unique here, so not lattice. Okay, so now again for this, if you take DE, okay, so if you take DE, so LUB can be B, LUB can be C. So again, not unique, so not lattice. Okay, so now this one, fourth one, so this is basically L2 star. L2 star we have already seen, this is not L2 star means this is a not distributive lattice. So distributive is property is not holding, but lattice. Okay, so this is lattice. So 2 and 3 are not lattice, other the diagrams are lattice. Okay, so now let's say this question, this was asked in GATE 2017, 1 mark question. So this might be our last question in this topic, so we'll continue with groups later, because I haven't found any more question. I gone through 2019 and 2020 paper also, but I haven't found. So if you have, so you can always tell me. And 21 paper, actually I haven't found the questions in the my paper set 2 questions also I don't have. Okay, so now let's see, because I have, I think, a GATE in the GATE website, but I have to check, I have forgotten the password and all. So let's do this. If I find, I will obviously upload. If you find, if you have some trouble, you can always mail me. Okay, so now let's see, this is an NAT question. The question may look big, but trust me on this, this is a easy question. Okay, so it will not take much of your time. Okay, so just it's looks big, and the thing is that you just have to read the question once, but it is not tough. So consider the set X containing these elements A, B, C, D, E under the partial ordering. So this ordering is given, but the diagram is also given. You can see, if I just move out, so you can see that diagram is also given. The Hussey diagram of partial ordering X and R is shown below. So this is our diagram is given. So now the minimum number of ordered pairs that need to be added to R to make XR a lattice. So actually they are asking minimum number of ordered pairs we need to add in this graph, in this diagram, Hussey diagram, to make it as a lattice. Okay, so you can always see that this is already a lattice. Okay, so you don't have to add anything. So this is basically the answer is 0. So I will tell you, when I was solving this question, I was thinking like 0, seriously 0. Actually I searched it online like 2-3 times to, like, you know, obviously gigs for gigs, gate overflow, RBR, search site, so many. Actually I tried finding out, seriously the answer is 0. So it is 0. Okay, so if you cannot believe this, but it is true. Back then I was not having such clear concept, so that I can say that yes, because when we are starting the GATE questions, so it might happen to you also, you might get wrong answers and all this, but it happens, but over the time it will be easier. Okay, so this is already the, coming back to the point, this is already a lattice, we need not add anything, so we have to add 0. Obviously need not add anything means we have to put 0. So from the virtual keyboard you have to like click the 0 from here. Okay, so all this. So next is we will see groups. Okay, so I'll upload these videos and we will see you in next video. So in meantime you keep practicing. Okay, so even if I cannot upload more videos, because you know my classes have started and I have my work, and obviously I'll try to make videos. And thank you for watching, and I'll keep uploading. I get messages that will you take tuitions, and also I am not taking any tuitions. I'm telling you, I am not giving any personal tuition to anyone. I'm replying to today only, I think I got a Facebook message request, and I told him that I don't give tuition. So I'm not don't think like I'm not giving you tuition, but I am generally I'm not taking any coach. I'm not doing coaching, online coaching or anything, offline anything to anyone. So it's not just you, it's for anyone. This is free, and I'll whenever time permits I will keep uploading. Okay, so I'll try to do more videos soon. Okay, so bye and see you in next video, and good night.